Sarah here with Signals Everywhere, and today I'll be showing you how to build your very own TV transmitter using AI, Go, and a HackRF. Don't go anywhere. So let's go ahead and build our TV transmitter. Now there's a couple things you're going to want to do before you get started. The first thing is going to be you need to have an AI that that has a large amount of context, and context is so important because it allows you to teach the AI how to respond to your queries. So the AI that I like to use for coding is Gemini. Now I do have Gemini Pro, but we're going to come over here and I'm going to switch this to 2.5 Flash, which is the more generalized version of Gemini. It's not actually for coding, but it's free and it's what you'll have access to. So I want to try to build this at your level rather than forcing you to go to a paid AI. Claude is also another good AI for this. However, Claude really doesn't have a good free tier. You're going to have to pay for it if you want to have that large context window. But if you want the most bang for your buck and you're going to go paid, I would definitely settle on Gemini. No sponsorship, just what I use personally. Now, before we go on to the next step, we need to actually figure out how to communicate with the HackRF. So I have here the HackRF library that I use by Samuel, and this is over here on GitHub under the BSD license. And if you look at the HackRF API documentation here, there is a Go Docs page, and this shows you everything you need to know, all the functions within the library that will allow you to communicate with your HackRF. So we're actually going to teach our AI how to build this application using this information, and then once the application is functional, we're going to go ahead and refactor it so that it is broken up into folders, similar how TV Live is here. And it'll make it so much easier to go in and make changes to your code in the future. It helps make it very maintainable. So we're going to do a full build that does a color bar TV transmitter. We're going to use the HackRF and the Go library, or excuse me, the Go language, and we'll use the HackRF library by Samuel to go ahead and transmit this information over the airwaves. So let's go ahead. I'm going to create a new project. Now this is PyCharm. However, you don't have to use PyCharm. You don't even need an IDE at all, especially for Go, but it is an option if you'd like to use something similar to it. I use PyCharm because it's free, and I was a Python programmer before I touched any other language. And I'm just going to name this AI tutorial, and we're going to go ahead and open source this so that way you guys have access to all the files that you see here in the video once it gets uploaded. Press OK. I'm going to trust the project, open it up in this window. Now I'm not going to show you how to do install Golang or anything like that. You're going to use whatever language is most comfortable to you, and I highly recommend that even if you're using AI to code, that you do have some programming background. It's going to make it so much easier to read the code, understand what AI is doing, and help give it feedback because AI does make mistakes. So the very first thing we're going to want to do is give it context of our library. So this is actually really simple. I'm going to come in here, I'm going to highlight this, and I'm literally going to copy this whole thing, and I'm going to give it to Gemini. So we're going to copy, we're going to come over here, we're going to paste that in, and then we need to give a prompt to AI so it knows what it's looking at. Okay, so we have our prompt here. This is the Go HackRF library. I'm a licensed amateur radio operator, and we're going to build a color bar TV transmitter in a single file using the library documentation I provided. And I also told the AI that this is going to be written in Go, with main Go being our entry point. So we've given AI all the information it needs, and you'll notice I did tell it that I am a licensed radio operator, and the reason for this is because AI will flag different things based on ethics and morals and stuff like that. So if it thinks you're unlicensed, it may refuse your request. So it's always important to make sure that you have the correct license and that you're transmitting in a way that is not interfering with other people. So let's go ahead and send it this prompt and we'll see what it gives us for our first result. Okay, and you can see that it did create a file here. So we have no idea if this is going to run or not on the first go, but we're going to give it a try. So I'm going to come over here, create a new file. We have main.go. We're going to paste that in here. And before we run this, before we even think about building it, we need to check out the code and actually see what it's doing. So first of all, we're going to be transmitting on 433 megahertz. That's actually a really bad frequency because we need to transmit on a TV channel. So we need to go to 427 42725, and that's going to transmit on channel 58 cable. We've got our sample rate here. Let's see. Sample rate is 10 megasamples per second, nice and wide. That's perfectly fine. Typically, a TV signal is going to be about 6 megahertz wide, so that gives us plenty of room to work around with. You can see there's a baseband filter, and we have our gain. I'm going to go ahead and turn our gain up to 30. And we're just going to come down here and take a look at the rest of the code, see that everything is kosher. And let's see, one thing I want to check here is whether or not it's trying to enable the amplifier on the HackRF. Always good to check things like this because enabling the amplifier built into the HackRF can actually cause the HackRF to fail and blow out its front end. We don't want that, so obviously it's just very important to check your code. Don't just randomly take code from AI and run it. You really do need to check it out and make sure that it's going to do what you want it to do. So now that we've done this, I can open up a terminal here. We're going to do go mod init, and I'm just going to call this tutorial. Go mod titty, or tidy, excuse me. I call it titty, but whatever. That's going to go ahead and grab the modules that we need for our project. And you see we actually do have an error here, so let's see what's going on. It was unable to find the package. Interesting. Let's go take a look at our imports real quick, make sure those are correct. And they're not. See, this is this library should be Samuel, and it's pulling it from somebody else. Somebody that doesn't even exist. So there's one of those mistakes I talked about with AI. It can do some stupid things. So let's go ahead and try that again. There we go, and it found the library. So very simple fix. Now we'll do go build output tutorial, and we'll see if it builds. And it did build on the first go, which is pretty impressive. So let's run it and see what we get. So it looks like we're not actually getting anything at all. So what we're going to do here is open up SDR++, and we're going to just take a look to see if it's actually transmitting, because I'm not getting anything on the TV. So we're going to bring this to 427.25. Alright, so there's 427.25. And let's go ahead and start this back up. And so you do see that there is a signal, but it's very dirty, and it's absolutely not a TV transmitter. In fact, we're transmitting tones, which is not what we want at all. So let's go ahead and give the feedback to AI, and we will go ahead and try this again. Alright, and so I'm just telling AI here that we're going to use this version of the file that I've fixed to use it the way I want it. And we want it to use ffmpeg to create the color bars instead of trying to generate them on its own. And we're going to tell it, please provide a full replacement file. Otherwise, it's just going to give you edits for your existing file. So having the full file is just a lot easier. And just while AI is thinking here, I can guarantee you part of the issue that we're having at the moment is the fact that I'm on the free tier. The Pro version does work so much better when it comes to doing things. And as you can see, it's actually showing me an error. So it was unable to process, and we're going to have to retry. So this is a process that can absolutely take you a lot of time to get through. It's finally rebuilding it now, but you can see it's changed all of our frequencies. It's changed all of the stuff in this file. So we may have to regenerate it again. Okay, and as you can see, it actually replied in chat this time. So we have our new file. And it looks like it did change some things here. It messed with the library import again. So let's just go ahead and copy this over. We're going to fix our import, and we're just going to double check that everything's kosher before we run it. 427.25, that's channel 58 cable. Still 10 megahertz, that's good there. Our bandwidth filter is perfectly fine because the NTSC signal is going to be about 6 megahertz wide. Everything's looking good there. And then I always look for enable amp or amplifier just to make sure that there's not anything in the code telling it to use an amplifier. So we're going to run our go build again. And it says time was imported and not used. So we don't need AI to fix that. That's simple. We're going to come up here and we're going to remove time and we're going to try to build it again. File is built and now we run tutorial and see what kind of output we get. And it looks like my TV turned off, so let's go ahead and turn that back on. And you can see we still have absolutely no output there. And if we take a look at our logs, it actually says that the ffmpeg stream has ended, end of file, transmission may stop. So in other words, something happened with ffmpeg and it has been unable to continue the transmission process. So it's not working yet. We're going to head back over to AI and give it some feedback on this code so it can make things a little bit better. So what we're going to do is we're going to take this entire log from runtime and we're going to provide that to AI. Please fix and provide full replacement file. Alright, and so some changes have been made to the ffmpeg here. And we're just going to go ahead and fix our import because it's still doing that. Like I said, you really have to be on top of AI. It will do some stupid things. But it looks like other than that, we should be fine. So let's go ahead and build. Again, time imported and not used. And that's just because we never told it that we had that issue in the first place. Simple fix. And then we'll run our tutorial program. And again, stream ended immediately. So something's not going correctly with ffmpeg. So what we're going to do is we're going to ask AI to add additional debugging so that way we can get logs from ffmpeg to tell us exactly what's going on. Like I said, context is very important. Just like you need context of a problem to solve it, so does AI. Please add debug logging for ffmpeg to the screen. Provide full replacement file. Okay, and so this is going to give us more debug information, so that way next time we run the program, we'll be able to tell AI exactly what's going on so that it can fix our problem with ffmpeg and thus allow our transmitter to continue its transmission. Alright, we run tutorial and now we can see exactly what's going on. So we have an unrecognized option mod type, which is causing the ffmpeg command to fail, and that's why we're not transmitting. So now we have more information to provide to AI that will allow us to fix this issue. And honestly, being that it's an unrecognized option, we can probably just come in here, look for mod type, there it is, and it was trying to use a modulation type of NTSC, which obviously doesn't exist. So we're just going to get rid of that. Let's rebuild it and see if this works. We don't even need AI to give this one a try. And again, we have S-rate. That's another one that doesn't exist. Let's get rid of that. And we're still having some issues here. So the best thing we can do here is actually, wow, it is so stupid that it's trying to do that. It's actually trying to modulate with ffmpeg, which it cannot do. I didn't realize how stupid the free version of AI can be. So we really need to give it more context here. So what I'm going to do is I'm going to print out the help information for ffmpeg, and we're going to give it all of this information along with our error. And that's going to help us basically teach the AI all the correct flags so that it'll be able to fix this error for us. So it's still trying to modulate with ffmpeg. That's just not going to work. So we're going to tell it we need to modulate with the SDR and that ffmpeg only provides video. For some reason, the free version of Gemini is being really stupid today, and you really need to know a little bit about what you're doing in order to get it to function the way you need it to. AI is not going to hold your hand through the entire process, especially if you're using free versions. You need to have a little bit of an understanding of what you're doing. Okay, so now we have a new copy where it's actually going to modulate the signal itself rather than trying to use ffmpeg, and we'll see if this actually works. Just double checking everything again, make sure it's all good. ffmpeg looks good. And see, we do have an enable amplifier this time. We're going to set that to false. We want to make sure that we're not enabling our amplifier. And let's build. Up, we have a time import again. Time. We're going to remove that. Build. And then run tutorial. Actually, before we run that, I have to turn my TV back on. Alright, let's go ahead and run the application. Alright, and there we go. We have full color bars on the TV. Now you can see it's not the most stable signal in the world, but we do have a signal. So we are actually getting our NTSC transmitter working with full color bars. Now you can see though, this code is 412 lines long. So we should really refactor it at this point now that we have a working base, and then from there we can build it up and make it a better application. So let's refactor it into folders, and then we'll go from there and actually build the application out into something a little more usable. So when AI gives you Canvas, it's great for single files, but it's absolutely horrible for refactors. So we need to tell AI that we don't want to use Canvas at all, and we're actually going to keep everything in chat. Alright, and the prompt I've given it is it's time to refactor this into something more maintainable. I want to organize everything into folders, with main go being the entry point at the top level of our project directory. You have to give it very specific instructions on what you want to make sure the refactor goes the way you're looking for it to go. Otherwise, it's just going to take things into its own hands and it's going to make some horrible assumptions. Okay, and so it's created our files here. So we have our main Go and then the NTSC modulator folder with a modulator and signal Go files. So let's go ahead and create these folders. Alright, we're just going to check everything like we always do to make sure everything looks kosher. And you can see it's enabled the amp again, so we're just going to make that false. We don't want the amplifier at all. And you'll see it's calling itself Go NTSCTX. So that's actually different than what we used in Go Mod. So we do need to update that real quick because I named the module tutorial. We can either change the module name or we can change the name here. I'm just going to change it here. And we're just going to check the imports on the other two files to see if they need any updates as well. Although they shouldn't because the main file is the only thing that's actually calling anything. Alright, that looks good there. Let's see if we can build it. So we've got a couple errors here, one in signal and one in modulator. So signal says math is imported and not used. That's an easy fix. And then in modulator, we have an undefined error. I'm going to copy this one real quick. And you'll see it's actually updating the signal file in order to fix this particular error. Even though the error came from modulator, it's because it's missing some context from signal. So we're going to go ahead and update signal. And because it re-imported math, we'll have to remove that import. And now we'll try to build it again. And we're having the same exact error again. So let's go ahead and what I'm actually going to do is we're going to go ahead and head over to ChatGPT. And what I like to do here, especially with small files, is if we run into a situation where the AI is not able to solve our problem, we'll take a look at another AI to have that issue resolved. So there's two ways we're going to do this. First of all, I'm going to copy the error, and then instead of copying just that one file, I'm going to provide context to the entire project. And the way that I do this is with a tool I have called CopyTree. And you can download this on our website at sarahsforge.dev. I'll put a link in the description, but CopyTree will take a tree output of your directory and then copy all of the files in it into your clipboard so that you can give full context to an AI about what your project is and how it functions. So we're going to do CopyTree for all Go files, and you can see it copied 389 lines, and it's in green, which means it'll work with ChatGPT. So let's go ahead and paste that in, and we'll see what ChatGPT gives us to fix our error. And the fix is just to add a conversion function that maps IRE values, blah, 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 normalized amplitude. So it's going to go ahead and fix this error for us, and you'll see that it's actually updating modulator.go, which is where the problem was in the first place, and it looks like Gemini took the wrong approach in fixing that particular error. So let's go ahead and wait for this to complete, and then we'll copy this on over and see if we're able to get it to compile. And we've got our time import not used. Let's get rid of that. Application builds. So we have a full refactor. Let's go ahead and run tutorial, make sure it still works. All right, we have our full color bars just like that. So it's working quite well at this point. This signal itself is not super stable, so we can definitely work on that from here. But now the modulator is in its own file, completely separated from your transmit framework. It keeps everything maintainable, but it also means that AI can't screw up pieces that you've already fixed. So once you have transmission working, you can focus on your modulator. Once you have your modulator working, you can focus on adding extra features. So it makes it really easy to build off of things. And of course, there's more than one AI that you can use for this, and when you're working with smaller files, it makes it a lot easier to go to some of those free AIs that give you, those limited GPT-5 and other types of, what do you call them, large language models that you have access to. I hope you guys found this informative. I've started using AI more and more in my development process because it's allowed me to do so much more, so much faster. Don't get me wrong, you're still going to spend hours upon hours getting things just right. But especially if you have pro models of GPT on things like Gemini, you're going to be able to get a lot done in a fraction of the time. Just keep in mind that you need to have context, and you might want to use tools like CopyTree, which will give full context to the AI of what you're doing. And again, you can find a download for that in the description below. I'll also provide full copy of the application in the description below if you want to take a look at the source code for that. And if you have any questions, comments, suggestions, let me know. And other than that, it was wonderful to have you all here. Huge thank you to all my patrons for your support, and I will see you all in the next one. Bye.